Hi, welcome back to AT Math. Today, 11.6, radical expressions. Now what does it mean by that? Well, an expression containing square roots is in simplest form when the radicand has no perfect square factors other than 1, the radicand has no fractions, and there are no square roots in any denominator. Still unclear? I understand. Take a look here. If I have the root of 2 over 72, now imagine all that is under the root. Notice how that is a fraction. One of the rules is inside the square root, or the radicand, if you will. What's inside the square root can't be a fraction itself. Therefore, what you do is you take 2 over 72, and we're going to go ahead and divide both by 2, top and bottom. So it becomes the root of 1 over 36. Now at that point, then a rooted fraction can be split into a root for both. In other words, a root on top and a root on the bottom. So root of 136 becomes root of 1 over root of 36. Root of 1 is 1 because 1 times 1 is 1. And root of 36 is 6 because 6 times 6 makes 36. You try. Go ahead. Let's see how you did. Hopefully you divided both by 3. So if you take 3 and 108 and divide both by 3, you get root of 1 over 36 again. Root on top, root on bottom, it becomes 1/6 is your answer. Now this, if you have root of 3 square plus 4 square, the first thing you have to do is you go ahead and square both these numbers. So 3 square becomes 9, 4 square becomes 16. Now add both together, 9 plus 16 is 25. Now when you root 25, you get 5. There you have it. You try, go ahead. Let's see how you did. 6 square makes 36, 8 square makes 64, add them together, you get 100, root of 100 is 10. Next, now this, x squared plus 16x plus 64, first break it into two binomials. So if you remember, what two numbers added make 16, but times that make 64, and the answers are 8 and 8. So you have x plus 8 times x plus 8, which becomes x plus 8 squared. Remember that when a square and a square root are together, they cancel each other out, leaving just x plus 8. However, for right now, put them as an absolute value of x plus 8. And why? Because you are rooting a square, therefore there will be two answers. More on that later. So go ahead and try it this time. Let's see how you did. What two numbers times make 81 but added make negative 18? I hope you know that is x minus 9 and x minus 9, which becomes x minus 9 square. Root and square cancel each other, leaving x minus 9 absolute value. Now, not all roots work out perfect. Work out perfect. Save that. So root of 18. Well, we can root 18, but it's not going to be a perfect number. What you can do is you can say root of 9 times 2. 9 times 2 underneath, of course. Now that becomes root of 3 squared times 2, because remember 3 times 3 makes 9. So we'll just split them apart. We'll say square root of 3 squared times square root of 2. Remember, square and root cancel, leaving just the 3. So 3 times root of 2. Root of 2 stays right where it is. Because they are touching, they are still multiplied. So your actual answer is 3 square root of 2. Once again, let's backtrack here. 18 breaks down to 9 and 2. So root of 9 times root of 2. Root of 9 becomes a 3. 3 gets to go on the outside, leaving the 2 left alone in the middle. In the inside. And that's how you do it. You try, go ahead. Let's see how you did. 98 breaks down into a 49 and a 2. Root of 49, root of 2. Root of 49 becomes a 7, which goes on the outside. Root of 2 stays inside, so it stays there. So 7 square root of 2. You try again, go ahead. Let's see how you did. 242. Now why does it become 11 square root of 2? Because basically you have 2 on the outside, and root of 121 and root of 2, and root of 121 is 11. Now this. Now if you have root of 32, I want to show you there's more than one way to solve this. If you don't know how to break it down, you can go ahead and break it in wherever you can. So let's say, well, I know that 32 is 4 and 8. Alright, so square root of 4 is 2, so it becomes a big 2. Now, you could say 2 times root of 8, but root of 8 also becomes root of 4 root of 2. And a root of 4 becomes another big 2. Remember, they're all times, and so they're all touching. So 2 times 2 makes 4, and the root of 2 stays where it is. So you have 4 root of 2. Or you could take 32 and take 16 to begin with. 16 times 2, because 16 times 2 is 32, both rooted, of course. Root of 16 is 4, and square root of 2 stays where it is. So 4 square root of 2. The point is you can break down a problem a little at a time or all at once. It makes no difference, because in the end it's all going to equate to the same thing. So you try. Go ahead and start busting up 1024. Go ahead. Let's see how you did. 1024, there's a couple ways you can solve it. If you don't know what to do, you can always divide by 2 if it's an even number. So 1024 will say, I don't know what that is rooted, so I'll divide by 2. So you take your calculator, take this, divide by 2, get 2 over here, divide by 2, you get 512. And it doesn't help you very much. Divide by 2 again. So divide by another 2, which breaks it to 256. Now the good news is, root of 2 times root of 2 becomes 2 square, and root of 2 square makes just 2. So that basically, when there's a pair of them, they get to escape, and they get out of the root and become a regular 2. Root of 256, again, maybe you don't know what to do. So just divide by 2. This divided by 2 is 128. Divide that by 2. Gets you to 64. These two roots of 2 become a whole 2. So you have 2 times another whole 2, which makes 4. Now you have 4 on the outside. 64, you could either bust up 64 and make 8, or we just start chopping them into 2's again. 64, 2 and 32, 32, 2 and 16. Square root of 2 become a whole 2. 4 times another whole 2 makes 8. So you have 8 times square root of 16. Square root of 16, you can break 2, 2 and 8, 8, 2 and 4. 2 times 2 is 2, big 2. 2 times 8 is 16. 16 times root of 4, well, hopefully you know root of 4 is 2 and 2, which just makes a whole 2. Whole 2 times 16 is 32. Or simply you can take your calculator and take 1024 and just root that and see what you get. If you can find it on the thing here. It becomes 32 as well. So either way, there's no wrong way to do this. Now when you have x squared and y to the 4th, they're all under the root, so this root's supposed to be under the whole thing here. What I do is I make lanes. Remember from classroom ago we talked about making lanes. So x squared is its own lane and y to the 4th is its own lane. And basically square root and square are going to cancel here, making x itself. So it just becomes an x. And when you root y to the 4th power, basically when you root you just divide by 2 here. So 4 divided by 2 is 2. Same by the way here. 2 divided by 2 is 1, which is x to the 1st. So that's the same idea. Anyway, you have x and y squared left over. That's what escapes once you root both of them. Let's go ahead and try another here. D to the 6th, e to the 8th. We're going to split them apart. D to the 6th over here being rooted, e to the 8th being rooted here. Basically, you're dividing the exponents by 2. So 6 divided by 2 is 3, so it becomes d to the 3rd, and 8 divided by 2 is 4, so it becomes e to the 4th. Now this, x to the 7th, y to the 4th. Now here it's an odd number, so it's not going to work out right. So we're just going to take one x off it. So you had 7 x's, so we'll say x to the 6th is here, and a single x is here. So we have 2 even numbers now. Well, divide this by 2, you get x to the 3rd. Divide this by 2, you get y to the 2nd. This x is left over, so it just sits there. So x cubed, y squared to the x. You try. Go ahead. Hopefully you notice that x and z are both odd numbers. We have to leave one of each. So x to the 7th means x to the cubed and one x left over. So x cubed escapes, x still is inside. Y to the 4th, however, is even. So if you divide that by 2, you get y squared. So y squared gets out. Z to the 5th, you have 4z to the 4th plus an extra z. Z to the 4th becomes z squared on the outside. Z stays in the middle. So you have an x and z still stuck in the inside. And this here. 24, x to the 4th, y to the 5th, z to the 7th. Basically 24 breaks down to a 4 and a 6. X to the 4th, we'll just say is x to the 4th. Y to the 5th, I make y to the 4th and a separate y. Z to the 7th, z to the 6th and a separate z. 4 rooted 4 is 2. 6 stays home. X to the 4th becomes x squared on the outside. Y to the 4th becomes y squared on the outside. Y stays home. Z to the 6th becomes z to the 3rd on the outside. Single z stays home. So it looks like this. If you notice again, 4 becomes 2. 6 stays in the inside. You might say 6. Can't we root a 6? But it's just a 6 is a 2 and a 3. neither of which can get out by themselves, so it's actually stuck. X to the fourth becomes x squared, y to the fourth becomes y squared, this single y stays home, z to the sixth becomes z cubed, the single z stays home as well. Now remember that a quotient property of square roots for any real number a and b, the square root of a divided by b is equal to the square root of a divided by the root of b. Long story short, if you have square root of 5/9, all you're trying to say is if you root 5/9, you can root 5 over the root of 9. So basically you can just split the roots up. Now why do you want to do that? Root of 5 is stuck, but root of 9 can become a 3. So root of 5, no change. Root of 9 becomes a 3. Because we can't root the 5 to a different whole number, it has to stay. Also, it's okay because there's not a root on the bottom. Because it's root of 5 over 3, that is acceptable to keep like that. You can't keep a root on the bottom, but you can have a root on the top. That's how it goes. So you try, go ahead. Split them up into 2 roots, see what you get. Go ahead. Alright, hopefully you have root of 7 over root of 64. And hopefully you know that root of 64 makes 8. So it's going to be root of 7 over 8. Not 7 over 8, root of 7 over 8. Why don't we change the 7? Because you can't really root a 7. It's just stuck. Now this is different. Root of 64 over 7. So we have root of 64 over root of 7. Root of 64 is 8. No problem there. But root of 7, you can't do nothing with. And you can't keep a root on the bottom. Got to fix it. So even though you cannot root a 7, we cannot leave a negative, not a negative, we can't leave a root on the bottom. Can't. It's a no-no. So, what are you going to do? Well, to get rid of the root of 7, I'm going to multiply the top and bottom by root of 7. Why? Well, 8 times root of 7 just becomes 8 root of 7, but when I take a root times the same root, they combine to form a whole number. So root of 7 times root of 7 becomes a 7, and that is acceptable. And why does root of 7 times root of 7 make 7? Because 7 times 7 is 49, or 7 squared, and the root of square is going to cancel, leaving just your 7. Just like if I have root of 4 times root of 4 equals 4. So your answer to all the way up top is 8 to the root of 7 over 7. You try, go ahead. Let's see how you did. Root of 121 over root of 72. Root of 121 is 11. Long story short, root of 72 is going to be 6 root of 2, because 6 times 6 was 36, and 36 times 2 is 72. However, we can't keep a root of 2 in the bottom. Therefore, I want to take these, which I have, and times the top and bottom by root of 2. So 11 becomes 11 times root of 2, or 11 root of 2. But root of 2 times root of 2 becomes 2. 6 times 2 is 12. That's your finished answer. You try again. Go ahead. Let's see how you did. Root of 18 over root of 44. Well, root of 18 you can make 9 and 2, and root of 9 becomes 3, so it becomes 3 root of 2. 44, however, I just get a 4 and 11. Now, root of 4 is 2, but root of 11 stays home. Nothing I can do with that. But I can't leave root of 11 on the bottom. To fix that, I'm going to times both by root of 11. Root of 11 times root of 11 is a whole 11, and 11 times 2 is 22. However, root of 2 times root of 11 becomes root of 22, so it's 3 root of 22, and there's nothing I can do with 22. Even though you might say, can I break it down somehow? Well, root of 22 is 2 and 11, both of which are prime, so there ain't nothing to be done. By the way, you cannot divide 22 and root of 22, so it's finished. In other words, you can't take, I'm going to divide these by 22. Doesn't work, because root of 22 is not a value of 22. They're different on different planes. They don't mix together.